and today I've got Sam joining me, who's going to help make the comparisons in this video. We had quite a few requests from customers asking us how do the KRESS robots compare to the AMBROGIO robots. So we've got our hands on one and we're going to run through the external and internal components on these two machines. The robots we'll be comparing today are the KRESS 123E mission robot and the AMBROGIO 2025 Elite.
So, to start with, this is the KRESS Mission 123E. So it's rated to cut an area of 2,000 square metres. It runs on an 18 volt system and has a 5 amp hour or 90 watt hour lithium ion battery.
So I've got the AMBROGIO 2025 Elite. This model is suitable for lawns up to 1,800 square metres. It has a 25 centimetre width of cut. This runs on a slightly higher voltage battery. This is a 25.9 volts with a 5 amp hour capacity and 129.5 watt hours. So let's familiarise ourselves with some of the components on the machine. We'll start with the top cover. Now this is made of a polycarbonate blended ABS. It feels really premium, it's very, very sturdy and has got a gloss finish on it. What have you got there? You've got a white cover as well, so
yeah, so the cover of this, the plastic that makes it is ASA plastic. It's a slightly more unusual blend of plastic. It's not quite as common as ABS. ABS you find on quite a lot of garden machinery. ASA's, and car bumpers, and ASA, not really come across it before. It's really difficult to convey sort of the feel of it. It doesn't feel cheap, right? It's not. It doesn't feel like sort of throwaway plastic products, but it definitely doesn't feel premium either.
It's got like a scratchy texture to it, hasn't it? Yeah,
yes, it doesn't have the same kind of smooth finish, but yeah.
Seems robust. On the 25 Elite, the bumper is this front bar here. It's actually a mechanical bumper, can move in any direction, forward and back, side to side. And the two front wheels also can act as a bumper. So if a low-lying object comes into contact with the front casters, it can actually activate the bumper as well. This machine also has the ability to detect a bump through the load on the rear wheels and using its gyroscope.
So the bumper on the KRESS 123E, it's got a floating top deck, and that acts as the bump sensor. So it's got a Hall effect sensor to detect sort of when it hits an obstacle.
That's very similar to how Husqvarna's top covers work, isn't it?
Absolutely, yeah. It's very, very, very similar design in that sense. But what's different from Husqvarna and some other brands that use the same kind of thing is you've got these two ultrasonic sensors. Now, they're very similar to the kind of sensor that you'd have in a car for your car parking sensors. So this is KRESS's Obstacle Avoidance System, or OAS. Essentially, it allows the machine to detect obstacles and steer away from them before it hits them, which works quite well.
So how close can it get to a solid object in the lawn then?
Approximately sort of 20 centimetres in front of the detection. So and the action of it is that it sort of interprets that obstacle and then steers away. So that's really nice in theory and it works quite well.
But won't that leave a lot more uncut grass?
Exactly. So the problem is your blade is actually positioned quite far back from your front bumper. So you see you've got that kind of distance there. So that is, about 15, 20 centimetres? I can tell you exactly.
15 centimetres. Oh, no, sorry, 25 centimetres.
25 centimetres.
Yeah, 25 centimetres.
And then, so that's about 10 from there, and then you've got another little bit that it's detecting.
So 45 centimetres from the cutting edge.
Around there, so it's going to leave all that area uncut. So if you've got permanent obstacles in your garden that you haven't wired off that the machine can cut around with a border clean, you're going to have quite a large area uncut. Now, this is really good for impermanent obstacles, so a person, for example,
pets
and things like that is really good for that. But if you've got permanent obstacles like trees or statue or things like
sheds
that,
and things,
you're probably going to want to wire them off and not rely on this. Otherwise, you'll have a lot of cutting around the edge of those to do.
You'd have to include them in the border loop, wouldn't you?
Exactly.
So it could to cut around it. But it's a nice feature.
Yeah, it's a good feature. I don't want to sell it short, but it is going to leave a lot of uncut area if you just rely on it for those obstacles that are permanent in your lawn.
So let's have a look at the operator panel on this robot. Unlike some of the bigger robots in the Ambrogio range, there's no screen on this machine. You've just got 4 very simple hot buttons, I like to call them, so they're the key things that you need to do. On and off, send a robot home, stop and start, automatic or manual mode, and then the stop button. These 2 studs here are the rain sensor, and then you've got a couple of indicators, LED indicators to tell you the status of whether it's in automatic mode or not, or the battery, whether it's charging or not charging. So what have you got on there, Sam?
So yeah, obviously the biggest difference you can see straight away is you've got a little LCD screen here. You've got similar buttons with basic functions, so on and off, I'll just turn that on there, you can see the screen light up. And then a start button, just set the machine off, and a go home button there to send it charging. The rest of these buttons are just for navigating the menu in here. So you can we couldn't figure out, we looked over the manual quite a lot, but we couldn't figure out why these are labelled A, B, C and D. As far as we can tell, they're just for navigating the menu in there, and this screen allows you to do basic programming on the robot itself. So if your robot doesn't have a screen, how do you do the programming?
Sure, so the Ambrogio app, which is available for Apple or Android, you can download, it's a free app. All of your settings are done via a Bluetooth connection with the robot, so you can put in your weekly schedule, set your rain sensor preferences, do 3 different timetables for different times of the year, so we call them working profiles. You could have a spring, summer, autumn working profile you can set up, so in the winter months it's not operating when it's dark outside and things like that. And once those profiles have been set up, this machine's actually got a GSM and Connect module built in, so you can select any of those working profiles from anywhere in the world, or you can send it commands like go home, work now. You can also track and trace it on the app as well and see where it is in real time. I don't know if it has the question.
Yeah, so KRESS, they have an app as well. To be perfectly honest, most robotic lawnmower manufacturers do. That's sort of fairly standard. So yes, your more advanced settings you can also do on the app. So things like adjusting rain sensor settings, working areas, that kind of thing. And unusually, it can also connect via Wi-Fi. So this machine can connect to your Wi-Fi network. You can interface with it through that.
You need to have good Wi-Fi in your garden, though.
Exactly. You not many people have Wi-Fi that stretches out into their garden, or at least not with very good signal strength. The other drawback or quirk of that is that it's then connected to your home network, which by extension the manufacturer can then connect to.
Yeah.
In terms of anti-theft, it has a PIN code, so if someone takes the machine, they can't actually do anything with it, they can't unlock it, they can't use it. What does the 25 Elite have? So
this also has PIN code protection via the app, so when you first connect with the robot via the mobile phone app, you're asked to decide a PIN number, which you can pop in. The other thing that, as an enhancement to the anti-theft on this model, it's got the Connect module in there, and you can set a geofence bubble around your local area, and if the robot finds itself outside of that area, the robot will send you an alert to the Ambrogio app, and you can actually track it in real time. It'll alert you that it's been taken out of area, and they can't switch the machine off. It disables the keypad, and you can actually see in real time where the robot is, which is quite a nice feature.
That is a good feature.
I'm guessing if it's Wi-Fi dependent on that one, then you wouldn't be able to, because...
No, once it's outside the network area, there's no tracking on the machine.
Yeah, okay. Right, so let's move on and look at the blade and height of cut and things. Mm-hmm. So Sam, I can see you've got quite a big knob there.
Yes, you're not the first person to point that out. So in the centre of this, you do have quite a large knob. So I'll just lift that up there. So that's how you set your height of cut adjustment. So you've got a little arrow there that indicates sort of where it is, and then you've got variance from 60mm to 30, and then you just change that just by turning it. And then you can, and then underneath the machine, that raises and lowers the height of cut. Now, 30mm, I think certainly for the British garden, is actually quite high. What does the
quite take the daisy tops off probably?
Yeah. So where does the Ambrogio cut down to?
It's 25mm, so it's about 5mm lower on this one. And there's a little bit more give in the tyres on this machine as well, so it can definitely take off the daisies and dandelions and things. Mm. The height adjustment is a little bit different on this model. It's supplied with an unlocking key which unlocks the deck and allows you to change the height. and this has got millimetre index along the side there, and you pop it in under the deck like this. Rather counterintuitively, to unlock the deck, you actually twist it clockwise. Once it's unlocked, you can then reposition the deck to the height you want that's on the index there, and then you lock it back off by turning it anti-clockwise. So not quite as slick as the as on the KRESS there. It's not something you're doing every day. You maybe set it at the start of the season and you're good for the rest of the year. But that's how the height is adjusted on this model.
Okay, so while you've got your machine like that, we might as well talk about blades.
Yeah. So I've got a 25 centimetre solid spring steel galvanised blade, as you can see just there, and that's got 4 cutting edges, and this blade is reversible. So once the cutting edge is spent or worn out, the blade can be turned over, or the robot itself will actually change the direction of the blade every 200 hours, so it can even the wear. So what have we got?
The total cut width of this is 22 centimetres. So you've got 3 razor edge blades here. So they're described as having 4 cutting edges because they are, in a fashion, reversible. So you can change the screw hole there to that one. So once you wear off that outer tip, you can then change it over to preserve the life of the blades there.
Again, looks very, very similar to the Husqvarna.
That kind of swing tip blade system. So typically, and again, it depends garden to garden, these probably aren't going to last longer than a few months. I would have thought. When the machine's cutting daily, those edges are going to blunt. How long would you expect that solid stainless steel blade to last?
So generally speaking, these are good for a season.
Oh right,
Should last a season. So Sam, I notice your blade isn't in the middle. Mine's centrally mounted and it's got equal distance either side. Yours is offset and there's a line.
No, you're absolutely right. And the blade on this machine is set off to one side. So it's offset, trying to get a bit more of a better edge cut. It's part of KRESS's side trim technology, SSTT. They love an acronym. If you look on this machine, there's acronyms all over it.
This is something that Robomow did many years ago, actually, offset the blade.
Yes, so the idea of a blade being offset from the centre isn't new, but it's also a bit of a gimmick, because actually, while the blade is over to one side quite considerably, when you look at where the blade tip ends up,
what's a ruler?
And you sort of line it up and you flay it out like it would be sort of as it's turning. If you measure that from the tip, it's about 4 centimetres to the edge of the casing. So that is an absolute value that you're not going to get less of, even if the machine is going right up to the edge of a wall or something like that. And the difference here isn't massive.
So it's just under 6 centimetres on there. But I suppose if you're going against a wall and you've got to trim anyway, the difference between 2 centimetres trimming against the wall and 4 centimetres is irrelevant.
Yeah, if you're going to have to be cutting the edge after the robot anyway, the difference between 4 and 6 centimetres, it's really not very much at all. And this only really applies to edges where there's a solid edge to it as well. Yeah, a cliff edge or a wall. If you've got a flush edge like a patio, it's actually irrelevant. Both these machines could cut.
You could just bring the wire closer to the edge and the wheel could run along the patio or the paved surface. If you've got 2 surfaces which are level, the grass and another surface, any robot can be installed to cut right over the edge. So the only real difference is on a walled edge or drop edge, isn't it?
Absolutely.
On those two. What's these 2 spiky bits of metal? They look like they might pick up twigs and things.
So this is the blade guard. So that's sort of your sort of extra protection against sort of catching the your fingers or your feet or something in the blade. It's metal. It does feel quite heavy duty. But you're right. The placement and the shaping of it's a bit odd. It looks like it could sort of pick up debris or twigs or things on the lawn, especially sort of on the lowest height of cut there. It goes quite low. Something else we noticed when we were sort of fiddling with these machines in general, there's actually a fair bit of play with the motor when you've got it when you've got the height of cut all the way at the bottom. no idea if that will cause any problems. It's just something we noticed and thought we'd point out.
If it's playing it from new though, it's can only get worse, I would have thought.
Yeah, absolutely. So you can see the height of cut action there.
Okay. Welcome back. It's only been a few seconds for you, but we've been actually off on holiday for the last 3 weeks, so if we look a little bit different...
Yeah, new tan lines.
Longer hair, yeah. That's why. So where we left off was we covered blades and blade guards. Now we're going to talk about handles, how you pick up the machine and handle it, and we'll move on to wheels and things. So I'll start with the 20 Elite. This machine has got 2 grab handles, so you can pick it up to show you on the camera there. It's quite easy to hold on to, 2 very, very secure handles, and helpfully this machine can actually sit up on its back end. So for maintenance, cleaning, changing the blade, you can actually just stand it up, or even for storage during the winter you can put it up on a shelf. Doesn't take up too much room, but that's how you handle this product. Okay,
so the handle on the KRESS, it's just at the back, so you just pop your hand in at the back, and I immediately noticed when I found where the handle was and went to pick it up, I thought that's odd that the top casing moves quite a lot. We were worried that something was loose or something wasn't assembled right.
One side, isn't it?
Yeah, on closer inspection that appears to be not necessarily by design, but that's how it is. So you lift it up at the back. There's no sort of second hand point for a hand except just putting it underneath the casing like that. You don't really want to carry this one-handed too much. It's not the lightest thing in the world. And then it doesn't really nicely sit up like the Ambrogio. So in terms of sort of inspection or maintenance, you'd have to either hold it up, lay it on its back, its side. But yeah, that's sort of how you pick up and interact with this machine physically.
Okay, so now you can see the underside of the Ambrogio here. Both robots use a 4-wheel design with 2 casters at the front, 2 drive wheels at the rear. The axle shafts on this machine are, I believe, 8mm thick. Just do a quick check on that. Yeah, so 8mm thick on there, and the diameter of the wheels at the front there are 4 centimetres by 9 centimetres. What have we got on there?
So I mean the axle shaft look about the same. I'll just double check that. Yeah, we're looking at sort of a little over. Yeah, about 8mm as well.
Yeah.
We'll do some close-ups of those being measured, and then in terms of the wheels themselves, so across the top there you've got just under 5 centimetre thickness, although what's actually in contact with the ground is 4 centimetres, and then the total width across diameter there is 9 centimetres. So
very similar
sizes, yeah.
One of the things I noticed on this, which is very different to the KRESS, is the front wheels are attached to a pivoting axle, so the front bumper can pivot up and down, and it can move in and out, which means that the front wheels are actually part of the bumper. So as it comes into contact with a low-lying obstacle that's below the line of the bumper, it can actually activate the bumper by the wheel pressing against something. So if you've got like a lip on the edge of the lawn, or a piece of garden retaining material, then it can activate the bumper there. And also the 2 front wheels themselves have some movement in there for drop-off sensors. So these 2 wheels, you can see they move up and down freely, and then in conjunction with the suspension of the front wheels, you've got a lift sensor on either side, and then the pivoting axle of the front wheels means that as this robot moves over undulations in the lawn, all 4 wheels are always in contact with the ground, so you don't get wheel spin or wheel slip. You've got very, very good surface area contact.
I mean, these arms are just fixed to the chassis, so there's no mechanical lift sensor there. I believe all the lift sensors the lift sensing in this machine is done by software rather than a physical sensor. But yeah, those axles don't really move at all, and that's it really.
Yeah, I mean, we can show the difference between the 2 designs by putting something underneath one of the wheels. So if we grab, we put that the KRESS user manual underneath the front wheel there.
Just pop that there, and you can see that you've got a sort of a gap there where sort of it's uneven, it's not flat, it hasn't got all four wheels contacted with the ground.
So the height of the undulation is what the adjacent wheel is lifted off the ground by.
Same thing happens if you have it on the back wheel.
Maybe you can show if you move it around to the camera there. The thickness of whatever the undulation is, the book in this case, directly transfers to the adjacent wheel, so it actually lifts off.
Yeah.
If we do the same thing on a floating deck design, you'll find that the wheels are always in contact, there's no movement at all. If I move that to here, again, the front axle just pivots and all four wheels are always in contact with the ground. So this just displaces the front wheel and puts the pressure down on the other side, and the two rear wheels are solid.
While we're talking about grip, something I noticed just while we were moving these machines around on this sort of quite smooth surface, the grip you get from the rear wheels on the KRESS is not very much. I don't need to put in any effort to sort of move that side to side. You can see that the wheels themselves aren't moving, whereas I need to put in quite considerable effort to do the same thing with the Ambrogio. It's not moving anywhere near as easily. So the rubberised treads on the rear wheel, their grip on this surface is
much softer material, isn't it? And gives a lot of purchase on there. You've got the movement from the knobbles on the tyre, but it actually really does have a very good grip, even on a smooth surface like this. So if you compare it to maybe some paving or wet. If on a wet day, some smooth paving, this is going to have a lot more grip in that scenario on a hard surface.
Yeah. And while we've got them like this, we might as well talk a bit more in detail about the rear wheels. So, in terms of size, so these wheels are ABS plastic, and then they've got a thin rubberised coating over the edge of there, and then these hard treads.
They are very stiff, aren't they? Stiff treads.
The thickness of these wheels is 4 centimeters, and then the diameter across the center is 20 centimeters. So 4 by 20, and then your sort of contact area with the ground is about 3 centimeters. So that gives you sort of a total surface area on each wheel of what's contacting with the ground of 12 centimetres squared.
Okay. So on the Ambrogio, they tend to favour these EPMD style tyres. It's a thick rubber, like what you get on car tyres. And these are actually gel filled, so they're very pliable. There's lots of give in them. Very, very soft compound. They are 10 centimetres wide by 15 centimetres high, and they've got like a self-cleaning rubber tread. So inside the treads there's a tread within a tread, and they get wider towards the outside. So as the tyre moves across the ground, it runs on a flat spot, giving more surface area pressure, but also helping to agitate and remove any build-up of debris on there. And that's one of the nice features of a flexible rubber tyre, that it can sort of allow debris to stick to it, but then peel it off as it dries and gets agitated off. So let's have a look at how much of the wheel is in contact with the ground. So if we look at the distance between the tyre treads, so we're looking at 4 centimetres, times that by the width of the wheel, 10 centimetres, so we've got 40 centimetres of surface area contact with the ground per wheel. That gives extremely low ground pressure to the robot, protecting the turf, but also extremely good grip. So there's lots of this nice rubber tyre actually in contact with the ground. It seems a huge difference between the two. Was it 12 centimetres on?
Yes.
Yeah. But the wheel is 4 times thicker, so that's where the difference comes from.
So next we'll just talk about charging contacts. So on the KRESS, they're located on the side of the machine. So the idea being, the machine drives in, sort of parallel parks, if you will, by the base station and then drives off. But that does somewhat limit where you can put the base station, because you can really only put it on the sort of along the edge of the lawn, because it has to drive in and then drive out. So you can't really do an off-lawn dock. You can't really do a corner. So yeah, you're just a little bit more limited in your base station placement because of the way that that charging action has been designed.
It's quite an unusual position for the charging.
Yeah,
I haven't seen that on many other robots.
It's a lot more common to see it on the front or the back, because then the machine can either drive straight in and then reverse out, or reverse into the base station. It is an unusual design.
Yeah, okay. On the Ambrogio, they're mounted in the front here on the bumper. There's two stainless steel contacts which drive in. It's allowed the robot to drive into the base station and make contact with the charging plates. This allows you to put the base station on the edge in the same way the KRESS is, but it can also go into a corner, or it can be installed off the lawn as well. So it gives you a little bit more flexibility on where you can place the base station. Right, we've had a good look at the external features of both these robots. Now we're going to get the tools out, strip them down, take them apart and have a look at all the components inside. Right, we've got the top covers removed on these two robots. I felt like I got the easier job.
Definitely,
it took quite a bit longer to remove all the fixings.
Yes, there's a lot of self-tapping screws to take out, so it took a little bit longer. But there we go, it's inside both of these units.
So just walk you through the anatomy that we can see straight away here. At the top, we've got the battery on the Ambrogio. We've got the AM4000 motherboard, mowing motor, GPS antenna and GPS module underneath. And below that is the bumper mechanism.
Yeah, and then along here, so the battery's mounted here on the side. Motherboard's here underneath this cover, presumably is where everything plugs into. Then obviously you can see the wheel motors at the back there. There's your blade motor there. You can see the height adjustment dial internally there. The
drive motors on the Ambrogio are located inside this tube. So we'll remove those in a moment and have a closer look at all the parts. Right, we've stripped all the components off these two chassis, so we're left with just a couple of bits that we didn't remove. The wiring that you can see here goes to the two drop-off PCBs at the front. They're actually glued in, so I didn't want to destroy those. I've left those in place. And below those, there's two circlips which hold the wheel shafts in. So we've left the front wheels on this chassis. The other cables that you can see are the two front wire sensors. So that's the chassis from the Ambrogio with just the front wheel and front wheel sensors left in place.
Yeah, and similarly, so this is the KRESS chassis. Also left the front wheels on because they're held on by single-use push-on fixings. Because these machines are going to go back together, didn't want to take them off because have to destroy them to take them off, and we don't have spares. Then the wiring you can see here again, front wire sensors. The rain sensor's moulded into the body there, and then that also connects down to the service port here, which is for dealer access. That's not really an end-user feature. And there's also this. Which is just a weight, just to give the chassis a bit more weight to it.
I guess it's at an angle there, offset to one side because it's the opposing side to where the blade motor sits.
That makes a lot of sense.
I guess that's what's balancing the chassis, because you've got a lot of extra weight on the right hand side.
Yeah.
So they put a counterbalance weight on the left hand side. I assume that's why.
That makes a lot of sense because the blade guard's metal as well and is relatively heavy. So.
Okay. So we'll put these chassis out of the way and have a closer look at the other components.
So next we'll have a look at the top covers. I've actually got two pieces. So first is this sort of larger top cover. So this top cover is actually used by Positech in their other brand, of robot lawnmowers, Works. Essentially, this white trim and this sort of red trim down here is the only thing that's different. They take that off. And put the, I think orange Works on it. Yeah,
orange, bright orange trim.
But you can see that just clips in the bottom there. So inside here, so you've got these flexible mounts for the cover. That's sort of how it operates the bump sensor on it. Interestingly, when we sort of found earlier, there was a bit of a play in the cover when you lifted it up. This is why these sort of come out like that on little swivel mounts. So it's got that on 3, but bizarrely not on this rear one. Not quite sure why that is, but that's why when I lifted it with the handle, the cover moved quite a bit. So that's sort of that small mystery solved. Then you can see I've taken off one of the OAS sensors. I've only taken one off because they're both the same. You can see that here, but they just sort of clip in the top there, and then plug into the machine with this cabling, and that's the cabling from the charge contacts there on the side. So that's.
It looks like you've got 2 magnets there as well for the bumper Hall effect
oh,
sensor.
Yes,
Those 2 magnets there.
Yeah, so when this encounters an obstacle and bumps, it's those magnets that activate the Hall effect sensor for the machine to realise it's bumped into something.
I think the Hall effect sensor's under this part of the cover there, so that section you can see moulds into that bit there.
Yeah, you can see how that rests inside there. And that's presumably what that little PCB governs as well. So, and then the internal cover, you've got the display, you've got the PCB for the display there. You've got the dial, which without the rest of its components doesn't really do anything. Yeah, that's sort of it. On the internal cover, there's not quite so much.
Okay, so on the Ambrogio, it's a single piece top cover made from a shiny gloss finish ABS. You've got the button panel and stop button and rain sensor integrated. On the underside, there's not very much to see. You've got the cable for the rain sensor, ribbon cable for the button board, and then you've got these brass threaded inserts for the securing screws. So the chassis is attached to this from underneath, and the stainless steel screws go into these brass ferrules.
It's worth mentioning that you've got those brass ferrules on that cover. This was held on by a lot of self-tapping screws.
Okay. Fine, so we'll put these plastics out of the way and have a look at the other components.
Okay, so let's talk blade motors. So in the KRESS we've got quite a substantial feeling motor. Just pop that there so you can get a good look at it. So the motors screw fit together rather than crimp, so that's generally a good sign of quality. Internally you've got race bearings on both ends of the shaft, so altogether it's a nice blade motor. It looks like it's well made. You've got a hex drive shaft on there for where the blade is mounted, so that's sort of the blade boss there. And then you've got on the wiring here you've got 3 connections here that come through and power it. So yeah, just a decent quality 18 volt brushless blade motor.
Moving over to the 25 Elite, we've got a 26 volt induction motor. It's assembled via screws, so it's hand assembled rather than crimped. It's got race bearings on the rear side and the output side of the motor itself. This is an aluminium blade boss where the blade fits onto. It's got a large heavy duty Molenex connector for the power with 3 connections on it.
So that's the wiring for the power. What's the second wire for?
So this second set of 6 connections on this black connector, that's actually for temperature monitoring and RPM monitoring. So the robot itself can understand how fast the blade is spinning and how much load is on it, and also monitors the temperature. So that's quite a nice feature and helps to extend the life of the motor, because if there's a situation where the blade is jammed or overheating, the robot's aware and it can monitor that. So it's a nice heavy duty industrial grade DC motor. Right, looking at the blades, let's start with the AMBROGIO 25 Elite. This blade is 25 centimetre in diameter. It's got 4 cutting edges and it's made of solid C75 spring steel, which is then galvanised. It's sharpened on both sides, so it's reversible. It can be taken off and physically attached the other way round, but also the robot can spin the blade in a different direction after 200 hours of mowing.
Yeah, and on the KRESS, so we've got a design that we've seen before on other robot lawnmowers. You've got these sort of these razor blades that sort of spin out in when the blade disc rotates in use. So you've got 3 cutting edges. These are reversible, so as one edge gets blunt, you can undo them, turn them over. Generally speaking, these stainless steel blades last about 4 to 6 weeks. So you wouldn't expect to get a whole season's cutting out of them. And then the mount they're on, I thought this was metal initially when I looked at it. The sort of the finish on it sort of evokes like almost a metallic finish, but it is plastic. Yeah, and that's a 22 centimetre cutting width.
Moving on from the blades, directly above it is mounted the blade guard. And on the Ambrogio 20 Elite, you can see it's got this thick rubber sheet on top of the deck. And the idea of that is it stops the grass from sticking to this surface, makes it easier to clean. And as the machine moves along and as it's vibrating along the ground, the flaps can move and agitate the grass off. And then we've got a grass comb all the way around the outside. So as the deck goes over the grass, it helps to stand the grass up, ready for the blade to come into contact with it.
Okay, and then the KRESS blade guard is not quite so much going on. It's a metal guard. It's quite heavy duty. There's not. I'll just turn this around so you can see that as well. There's not protection all the way around, but that's because the blade in the KRESS is offset, so you don't need it on the other side because the blade is so far away from the edge that it's a non-factor. Just for reference, the blade when it's spinning comes to around here. But yeah, that's it. So metal, quite heavy duty, but not really any other features on it. So now we'll take a quick look at the drive motors. So there we go, there are those for you. So on the KRESS one, again, very similar to the blade motor. It's a screw together motor, brushless, bearings on both ends of the shaft. We can tell it's decent quality, but the planetary gearbox and then the motor itself, they're not branded, so we've got to assume they're Positec's own brand of motor. Like I say, the quality looks good, but yeah, like I say, we don't have a brand to work with on that. I will just note that the mounting on this, the manifold here where it screws into the deck, is plastic, so that mounting point is not necessarily as strong as it could be.
Okay, moving on to the Ambrogio 20 Elite drive motor. So here we've got a cast aluminium manifold where it fits into the transmission tube, a steel hexagon drive which goes inside the wheel, and the gearbox. This is the planetary gearbox here. That's actually made by IMS in Italy. It's a really well-known make of industrial gearboxes. They produce gearboxes for all sorts of industrial applications. And the motor itself is also branded and made in Italy. It's made by Fizzy, and it's again famous for motors that go into photocopiers, printers, and many industrial applications. It's got 2 connection leads on it. This is a 30 amp high rose connector with 3 connections for the power, and then there's a secondary cable which looks at the RPM and temperature of the motor. So you've got 2 separate connections there, one for that monitoring and one for the power. It's a screwed together style motor, so it's been hand assembled rather than crimped together, and really nice quality.
Yeah, I didn't mention, but yes, the cabling connection on this. There is one, again, exactly like the blade motor. It's just for the power. There's no sort of monitoring.
So if you can see there, the wires, it's side by side. Moving on from drive motors to the rear drive wheels. So this is the one from the Ambrogio 20 Elite. It's 10 centimetres wide by 15 centimetres high. Inside it's got a 5mm thick ABS plastic inner hub with a tyre on the outside which is gel filled. It's full of a really nice squishy durable foam. So that's the wheel from the Ambrogio.
And the wheel for the KRESS, again ABS plastic, so the construction of the wheel hub itself is quite similar, but what the KRESS doesn't have is a sort of a soft outer to the wheel. It has a kind of rubberized finish and quite an aggressive tread on it, but there's no sort of softness to it. It's sort of a solid wheel essentially. I will say, we've looked at a lot of robot lawnmowers, and this is definitely one of the better wheels we've seen.
Yeah.
But it just doesn't quite have the same level of traction being a hard wheel.
You can see side by side the diameter is quite different.
Yeah, so you've got a 4 centimetre wheel thickness here, and then a 20 centimetre total diameter across it.
And then 10 by 15 on the Ambrogio.
So we're going to move on to batteries next, so we'll just pop those on there. So the KRESS battery is an 18 volt lithium ion battery with 90 watt hours or 5 amp hours. On the branding it says it's made by Positech. There's not really much more information on it aside from that. Specification wise, I think that's similar to your battery but not quite as powerful.
Yeah, similar. So this is a more powerful battery. It's 25.9 volts, 129.5 watt hours at 5 amps. So it's running on a higher voltage than the KRESS at 18 with the 25.9. Yeah, so very similar form factor. It's a little bit bigger than the KRESS, but it has greater capacity. So that would be
That sort of makes sense, doesn't it? Yeah.
Right, now we've been through all the major components, we're left with two which aren't common to both robots. This is a GPS and GSM module which is found on the AMBROGIO 25 Elite. This has got an integrated SIM card embedded in the board and GPS chipset. So what you're looking at here is a GPS and GSM chipset there, and you've got an antenna for the GPS aerial and then an antenna connection for the GSM aerial. This runs on 4G and it allows the robot to establish its position, and it uses this to assist its navigation. So during the planning of the robot while it's on the lawn, it spreads a grid over the garden in 2 metre by 2 metre squares, and as it enters a sector that's not been into for the last couple of days, it can put a spiral cut in, and this improves the efficiency of the mowing. But it also allows the user via the mobile app to see the robot's position at any time. So they can log into the app, click on their robot, they can see where it is and they can see it moving on the lawn. It also allows an additional security feature, so you can put a GPS bubble around your property, and if the robot leaves that bubble, then it can alert you and start tracking the robot. So it's a safety device for security if it gets stolen. The 4G connectivity also allows you to send the robot commands from anywhere in the world and send you information if there's a problem or the robot gets into trouble, then it can send you a push notification to say that it needs your help. So that's the 4G Connect module.
Okay. And then on the KRESS, you've got the OAS, the Obstacle Avoidance System. So the machine has two of these. What it is, it's an ultrasonic sort of detector, the same kind as you'd have on a car for the parking detection. So when you sort of back up into a space and you get sort of beep 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 to let you know you're getting close to a wall, it's the same kind of sensor as that. So the KRESS robot uses that to detect obstacles before it reaches them and then avoid them. Okay. We're going to have a quick look at the base stations because the way the KRESS machine docks is so different. It's worth looking at what kind of base you get with them. So this is the base station that you get with the KRESS. Immediately you sort of see that it's got sort of this kind of grid or grid is the right word really. I was going to say mesh, but it's not really a mesh. But that does allow grass to grow through, so you're going to have to trim that in some capacity to sort of keep that tidy. You've got sort of like moulding grip there to help the machine on, and the machine comes in sort of sideways. So as we said earlier, you've got the charging points on the side of the robot, so that drives in along the edge of the lawn and then goes there onto those sprung connectors, so you can see sort of the movement action of those there. Then your wire follows these tracks in the centre into there where your wire connectors are, and then with the base station, I actually quite like this design, I have to say. You've got sort of stakes that they're corkscrewed and they screw into the ground, so you sort of pop them in and screw them in with an Allen key or a socket wrench, whatever's easier for you.
It's quite a nice
Comes
design,
with an Allen key.
Yeah,
I just thought that was worth raising. And then in this little bag you also get a few sets of spare blades, which is nice, especially when your sort of expected life expectancy of the blades is about 4 to 6 weeks. So the fact that it does come with some spare is good. And then in terms of power cable, you've got about 6 meters of it, and then the power supply is 30 volts 20 volt, 3 amp, and then it doesn't have an IP rating. It is designed to live outdoors, but it doesn't say what the IP rating on it is.
It looks like it's weather resistant, doesn't it?
Yeah.
Okay, so looking at the Ambrogio base station, this is for a forward docking motion. So the robot drives into this, presses against these two spring-loaded contact plates, which are quite wide, and charges up, and then it reverses back out and goes to find its area or start mowing. The base plate itself is a solid design to stop grass growing through and reduce the need for strimming. It's held to the ground with a bag of these supplied, they call them nails, but they're pegs really, and you hammer those in to these holes you can see here, and that completes the deck, so there's no room for anything to grow through there. The wire, the perimeter wire, is placed in this channel here and connects in underneath the base station head on the two connectors. I think that's the same design as what you see on there.
Same kind of design, yes. You can see the positive and the negative terminal that sort of just catches and bites the wire. I do just notice that the indicator light on the Ambrogio one is just on the top.
Yes, that's right.
I found it quite interesting. The indicator light on the KRESS one is here, which would be behind the robot. So when the robot's charging, you can't actually see any sort of indicator on the base station. Odd design choice, but that's where that indication is.
This indicator changes colour and flashes in different ways to tell you different things. If the robot's out in the lawn, you'd expect to see that flashing green. If the robot's in the base station and charging, you would expect it to be solid blue. If there was a problem with the perimeter wire, you would see that go red. So it's a multicoloured LED that gives various different bits of information. Inside here, there's a transmitter board that sends signals to the robot. So as the robot approaches the base station, it slows the drive speed down, or it can make it get back on top of the wire. This has a system where the robot can follow the wire slightly to the side of it, and to cancel that so it gets back on and in line with the wire, it sends that signal out telling the robot that it's nearby. Also inside here there are some settings that can be changed to adjust the channel that the robot works on. So if you've got a neighbour with the same model and he's already on channel 1, which is the default channel, you can actually change the settings inside this base station, change them on the robot, and have up to 8 different channels to make sure you don't get any interference from neighbouring robots. So we'll open up them both and see if the KRESS has got the same functionality, and have a look.
So back plate just pops off like that. I was just taking that off. So you can see here sort of the sprung action of those contact points for the charging. You've got the sort of the cabling there that comes down, and then the positive terminal activates this little arm here. It's got a magnet in here, so presumably there's a Hall effect sensor just underneath it that tells the station that the machine has docked, and then you can see sort of the board of the base station here, again sealed with that same kind of silicon gel we saw on the motherboard earlier.
Okay. So inside here we can see the underneath of the charging contacts, which are spring loaded with these large springs here, and then the power connections to each of the charging plates. And inside we have this transmitter aerial, which is sending details to the robot to tell the robot that it's approaching the base station. And we have some dip switches here, and these dip switches are what are used to set the channel of the transmitter. So the wire that goes around the lawn has an encoded signal in that the robot's looking for, and that can operate on 8 different channels. So one of the things I have just noticed is the thickness of the cables used on the two is quite different. We probably should measure the thickness of those.
And I think that's consistent along pretty much every component we've seen that is wired. The thickness of the cabling is different.
Yeah, so that's around 4mm cabling on there.
Yeah. And then that is just over 2mm.
Just over 2mm.
Yeah,
so they are quite a bit thicker, and you get 10 metres of low voltage power supply cable that goes to the base station, and that connects into a 29.5 volt power supply, which is rated to IP65. So this connector, the end of the run, connects into here. You'd locate that in a dry location, or use an outdoor power supply box, a dry box, and make that connection. That plugs in to there. Okay. So are there any different channel options on the KRESS robot?
No, not as far as I can see anyway.
Okay, so you can't adjust the frequency in which the robots...
No, because this board is potted in silicon gel, there's not really anything you can do with it. So one last thing I did also just want to mention, struck me when we were taking the machine apart. This may not be as relevant if you're a consumer, but certainly as a dealer for servicing these machines. Just show you, these are all the screws I had to take apart to strip my machine. And that's sort of what you've got in the Ambrogio. And the vast majority of these screws are sort of Phillips head plastic self-tappers.
They're machine thread stainless steel screws that go into brass ferrules on the Ambrogio. One of the things that I did notice and I thought was strange is they used a huge amount of Loctite on the wheel nuts, and
Yes.
it's the red Loctite, the very, very stiff, hard to remove one.
So you can
took
see
two of us
that
to take the wheels off.
Yeah, when I was taking it apart, I could not get the wheel off just by myself. So interesting to know. So that brings us to the end of our comparison of the KRESS Robotic 123E
and the Ambrogio 25 Elite.
We really hope you enjoyed the comparison we did here today. It's really just a component level comparison, so we've presented what we've found. You make up your own decision. We'd love to hear comments from you, and please remember to like and subscribe. And have we got anything else in the pipeline?
Yes, very soon I'll be doing a review of the brand new 4.0 four-wheel drive and 4.36 four-wheel drive. These are really exciting machines that have got steering front wheels, driving front wheels, and they can actually steer with all four wheels. So amazing bit of kit, and hopefully we'll be doing a video of that very soon.
Yeah, fantastic.
Thanks for watching.
Thank you.